Microphone going. Cool. Awesome. Awesome. All right, evening, boys and girls. Welcome to the party. My camera is working again. Yay, fun. Okay, so we're going to get straight into it. Everyone's joining nice and early, which is super duper. Okay, so let's start with the class. And from the beginning, coolsies. As always, we start off with, ooh, let's go back, the book of the week. This is another one of my favorite books, Evolving Eden. It's an illustrated guide to the evolution of African large mammal fauna. A really good book to have. Kind of hard to find, but if you shop around, you can find it. Also, it's available online. Just really interesting, gives you insight into where Africa was 20, 30 million years ago, where it was 4 million years ago, and how it kind of ended up where it is today with its plants and animals, specifically with the animals, and how they affect the plants. Really interesting book. Okay, so kicking off from last time, we're going back into the Caniforms. We ended off with bears last time. This week we're going on to seals, the pinnipeds. Okay, everyone loves seals. Okay, so seals have been around for a really long time, a lot longer than modern dogs. They originally evolved from mustelids around 50 million years ago. What's a mustelid? We're going to talk about that today. They have homodont teeth, which means their teeth are all basically the same. They're not specialized. And the reason for that is because they are specialists in fish, and they want these mouthful of piercing, pointy, needle-like teeth, which just allows them to grab their prey far more effectively, which is predominantly fish, and certain areas they also eat crustaceans. So the largest pinniped is the southern elephant seal, which weighs over 3,000 kilograms. In fact, the largest ever recorded was 5,000 kilograms. It's the weight of an Asian elephant. It's a bloody big predatorial animal, just huge. And they're limited mostly to the poles and western coastlines. You don't find them in tropical areas. You find them on western coastlines, which tend to have those more temperate Mediterranean climates. You do get one or two freshwater species, but most of them are limited to the poles. And they have a nictitating membrane, which is a membrane much like birds and much like your cats, which is this layer of skin that actually is like a third eyelid, which folds over the eye and protects them when they're diving. So they can actually still see even though their eyes are closed. Not like their normal eyelids, which are completely shut. So they tend to live in large colonies on land, okay? When I say land, it means anything out of the water. It doesn't necessarily mean gravel or soil. And they have large numbers of pups, and the waste they create provides a significant amount of food for shoreline predators and other scavengers. So depending on where you are in the world, bears will eat them, wolves, coyotes, jackals will eat them. So they are important as well. A lot of the bird species will pick on very sick and weak pups and end up just knocking them out of the gene pool and having a munch on them. Also, the waste itself is heaven for flies and for various sorts of insects. And it just creates its own little habitat. So they actually have a very important ecological function. So many species of seal also play an important role in the population control for bivalves and crustaceans. Bivalves are any of your shellfish, really. Clams, oysters, mussels, etc. And without these guys, their populations would just bloom and explode exponentially, and they would outcompete everything else. So seals are important contributors to that. They can just go through masses of mussels in one day. And they're also a major, if not the only, food source for orcas and large shark species. If you've ever done the trip in Cape Town, and if you've ever looked at Robben Island, and the seals that live on the island run a gauntlet between the mainland and the islands near Robben Island all the time, and they just get hammered by the great whites. And orcas in those areas hunt them as well. And without the seals, those sharks start to disappear. And that's one of the reasons why the seal populations have exploded so significantly in the last 50 years, is that we've annihilated the orca and especially the shark populations. Great white populations, I think, are only 5% of what they were 100 years ago. And that's why the seal populations have exploded. And the seals are also out-competing the penguins. The penguins are not really attacked by many predators, occasionally by the seals and occasionally by orcas. But usually they're quite safe. Not many things really go for them. They're just mostly bone and fat. So it's really just being outcompeted by the large number of seals lately that's driving the penguins to extinction. And of course, the loss of food, and the seals are just better at getting the food than the penguins. So yeah, this is a seal skeleton. You can see when it comes down to the basic brass tacks of it all, you can see there's not much different really from other mainland land-based predators. They've got arms and legs. They're just modified into flippers. The tail also comes down. They're quite robust built. Their head is quite small compared to a lot of other predators, but in line with a lot of the caniforms, it's not that strange. The feliforms tend to have much more robust, larger skulls, the bears being the exception. So there's not much difference there, and they have significant layers of just blubber around them as well, which just keeps them insulated and warm. And that's a skull over there. You can see homodont teeth. All the teeth are more or less the same, no real specialization. They don't really have much of a carnousal shear anymore because they don't need to. They need to be basically like crimpers or clampers. They just need to grab onto the fish and go nuts and break down shellfish as well. There doesn't need to be any real chewing function or shredding function. So they hunt solitarily within large groups. So huge numbers of them will go out at a time, and they'll just pretty much take their own prey. They don't hunt cooperatively. They might herd cooperatively together, but they each take their own food, and they don't share kills. It's a fish. There's not much to share. Most fish or shellfish, but larger species are known to prey on penguins and other seals. Like fur seals have been preyed on by sea lions from occasionally. They have highly sensitive whiskers, incredibly sensitive whiskers, which we call mechanoreceptors. And these are used for detecting prey in murky water through vibrations. They actually pick up the vibrations in the murky water, much like a fish has these sensors on its body. Seals have the sensors in a different capacity in their whiskers, and they can pick up very, very minute vibrations, and they can hunt just with those without seeing a thing. Smaller seals generally hunt by chasing or foraging, while larger seals tend to be ambush hunters. As they wait for things that are lurking at the top of the water, and much like a shark, they come up from underneath and hammer it and grab it and pull it back down. Being slower and more robust, they need to hunt by ambushing. So we're going to talk about three types of seals today. The first are the PHOCIDS, the earless seals. And there's a joke that I like to tell with my guests, and the reason why they're called PHOCIDS is because when you get bitten by one, you'll say, oh, fuck it. So, they're considered to be the true seals. They don't have fur. They're also much more streamlined than fur seals and can swim further for longer. They're extremely specialized for aquatic lifestyles. They have no external organs. Their penis is completely sheathed inside the body. They have nipples that actually retract back into the body. Their ears are completely internal except for tiny little holes, and they just basically build like a fish. They can hear up to 70,000 hertz underwater. Humans on land at our best can only have to 20,000. So they have phenomenal underwater hearing. Outside of water, comparable to humans though. They're generally furless, but they have dense layers of blubber, again for keeping warm, and they have no visible ear, genitals, or mammary glands. They have them, they're just underneath all that fur, and under all that blubber. And the nipples actually come out when the pup is feeding. So it's quite fascinating. And okay, so today there are over 18 species and 14 different genera. They're mostly limited to the colder climates. We have one, which is the hooded seal, the strange fellow over here, quite interesting looking. We have the ribbon seal, who's my favorite, super cute little fellow. And the southern elephant seal, which is a bloody monster. So he's just gigantic. You cannot imagine the size of this creature. So yeah, monstrous. The next group are the OTARIIDS, which are the eared seals. And they're distinguishable from earless seals because they have small ears and larger flippers. They're capable of walking poorly on land. So true seals really have a hard time. They can flop onto the surface, they can roll around, but don't expect them to do much movement on land. They really are just built purely for water. Whereas the eared seals can, if you've ever been to Cape Town and you've seen the Cape fur seals, you can see they can get around on the shoreline. Not well, but they can get around. So their skull is more dog-like than other seals. In fact, if you had to compare it next to a canine, a lot of people could easily get them confused. So they have the greatest sexual dimorphism of all mammals. So the males are up to 6 times heavier than a female. So a Cape fur seal, males are 300 kilograms, a female's only 60 to 80 kilograms. So it's a significant size difference. They have coarse hairs covering their body, and very few species occur in the southern hemisphere. They're mostly limited to the southern hemisphere. Very few species in the north. So the eared seals are quite boring in the way they look. They all look the same. 17 species amongst 5 genera, and they're divided into 2 subfamilies, which are the fur seals and the sea lions. We have the Cape fur seal, who's this fantastic little charming fellow over here. These are a bunch of girls. And we have the Stellar sea lion, who's a big meaty boy. And last, the California sea lion. Again, there's not much difference in appearance of the species, and it's very hard to identify them if you don't know your seals. It's a sea lion. The sea lions are significantly bigger, and the fur seals are smaller, but beyond that, they're just brownish, really. The last of the walrus. And historically, until about, I think about 5-6 million years ago, there were dozens of species. And through a series of ecological collapses, most of the species have gone extinct, and today there's only 1 species alive, who is just called the walrus. Now, breeding. Most species are extremely polygamous, which means they have 1 male and has many females. And the males are usually much larger in fur seals, and they will compete over large harems, and occasionally younger, smaller males get killed. The mating occurs on land. And walruses and true seals, there's not as much sexual dimorphism. They're roughly the same size, and they'll mate in the water and actually give birth on ice. So they don't like to live on the land. They are specialists, and you barely ever see them. So the females must fast when they're nursing. This is due to the long distance hunting grounds. So sometimes their hunting grounds will be 300 or 400 kilometers away from where they actually have their pups. So when they're actually giving birth to pups, they'll load up on food, get as fat as possible, and they'll just nurse the pup until the pup's independent, and then they can get back into the water and go hunting. Because they'll spend weeks out in the water sometimes before coming back to land. So we've lost 2 species in the 20th century. The one of the Japanese sea lion, hunted to extinction for its pelts, and the Caribbean monk seal, which was also hunted partly for its pelts, but also just due to habitat loss. It was outcompeted with humans because it was seen as a threat to fishermen, so they just systematically eradicated them wherever they went. So these 2 species went extinct. And again, not very different in terms of their appearance, but nevertheless, we lost 2 species. Okay, so the MEPHITIDAE, which are the skunks. We're now getting onto some interesting animals, and skunks are really gross. So they all have highly developed anal scent glands, and it's repugnant. They're limited to the Americas, and interestingly, Indonesia, Malaysia, and the Philippine Islands. And our ancestral fossils found throughout Eastern Asia, but they've all gone extinct on the mainland for whatever reason. It could be due to climate change, it could be due to glaciation, it could be due to competition with other predators. It's up for interpretation. So today there's 12 species alive, most of them in the Americas. I think 9 species in the Americas, north and south, and 3 species in Malaysia, Indonesia, and the Philippines, respectively. They all look much of a muchness. There are some differences, but we're just going to talk about the striped skunk, which is probably the most common of all of them. I'm sure we all know the striped skunk. And that is a skunk skull. And again, when you look at the skull, there's not much difference to a bear skull. And actually, when you look at badger skulls, which we'll look at shortly, you can again see they're quite related. The AILURIDAE, which are the red pandas. And a lot of people say, oh, it's a panda, is it a bear? No, not in any capacity. They're actually closely related to raccoons. The name panda is just because it's got white around its eyes. And they're not related to giant pandas in any capacity beyond being caniforms, but caniforms go back over 50 million years. And they're only found throughout southern Asia and mountainous areas, pretty much running along the northern extremity of the Himalayas right through into China. That's where you find the distribution range of pandas, of red pandas. And again, there used to be, there used to be many species until the last couple of glaciations. And this last guy, the red panda as we know him today, is the last surviving species. And he seems to have survived because he's a mountain specialist. All the species in lowlands went extinct as recently as 100,000 years ago. And the hypothesis, which we can't really test, is that they were just outcompeted by other predators, and also glaciations put pressure on their habitats. And just between the 2 of them, most of the red pandas went extinct. So we have one species alive today. Raccoons, who are cousins of red pandas, and they are highly adaptable and omnivorous, and they are prone to rabies. That is one of the tragedies about them. They're often kept as pets as well because they're highly intelligent. Their carnassial teeth are underdeveloped, and this is mostly because they don't go for large prey. They don't need to waste the energy on strong chewing power. They're mostly scavengers, and they eat small insects, they eat lizards, they eat snakes, and they actually have like rodent-like hands, almost opposable thumbs, where they can actually grip and manipulate things and pull things open. And that, coupled with the underdeveloped jaws, has given them this incredible level of intelligence, which we only find in comparable species like the badgers. They are limited to the Americas, but they have been introduced to other parts of the world. They're an invasive species in Japan because they were kept as pets. And they've invaded Japan, but they're not too ecologically damaging as far as I understand from the reading that I've done. They're an extremely diverse group with numerous niche specialists. So the raccoon is the most well known, but there's some other species. And again, we'll look at some species here that gives you signs of evolutionary convergence of different species evolving into similar looking species. So there are 13 species today. South America has the highest species count. The kinkajo, which looks almost like a bush baby, in no way related. I mean, bush babies are primates, but an ecological equivalent, and it has evolved through convergent evolution. The raccoon and the eastern mountain coati. There's quite a few coati species, but this one is the most well known. And again, they're kept as pets, unfortunately, but they can be quite aggressive, much like raccoons. The kinkajo is critically endangered due to habitat loss, and probably won't survive more than another 50 years, to be brutally honest. Okay, so the skulls again, if you look at skunk skulls we did earlier, and again with raccoon skulls, almost identical. The only difference is they don't have a significant carnassial shear. These will connect together, but they're not these highly developed carnassial shear teeth. Now, the Mustelidae, which are badgers. Everyone loves badgers. So they're an extremely diverse family comprising around 60 species. And we're going to spend quite a bit of time on Mustelidae today because this is probably one of the questions that people ask a lot of questions about. And mustelids are well known for being highly intelligent and voracious predators. I'm sure you all know about the honey badger. And they have elongated bodies, short legs, rounded ears, and extremely dense fur. And they're found worldwide except for Australia. Remember, placentals, except for some rodents and some bats, don't occur naturally in Australia. And obviously New Zealand, there's no mammals occur naturally in New Zealand. And all use strong-scented anal glands for either marking territory or sexual signaling. It's not as strong as skunks, but they're pretty nasty regardless. So, ecology. Mustelids all have high metabolisms and are important rodent and reptile control predators. So they go through huge numbers of rodents. Something like the least weasel, for example, can eat up to 60 mice in the course of an evening. They've had record numbers of up to 60 mice being taken in one night. And many mustelids are highly skilled burrowers and provide holes that are used by other animals. So snakes, other rodents, even some birds like ground nesting owls will actually use the nests of badgers to live in. And like bears, we talked last time about embryonic diapause, and allows them to become pregnant, truly pregnant, at a more suitable time. So we're going to talk about the badgers. Now, there's 4 subfamilies today, and that really depends on where they evolved in the world. The Taxonidae, the Melivorinae, the Melinae, and the Hectodinae. And there's 6 species worldwide, 4 genera. They're found worldwide, except for Australia. And several species are known to be immune to snake venom. We're going to talk about this. And all species are highly intelligent with well-developed brains and problem-solving abilities. And again, this just owes to their habitat. They are problem solvers by their entire lifestyle. Their entire lifestyle is to figure out how to get to food. And again, you can see when you're looking at these animals, the skulls are not that different. They are so similar. There's not much difference. The only difference with this guy, he has a really pronounced sagittal crest and some real chopper jaws over here, and quite pronounced canines. And his eyes are fairly underdeveloped. He's got quite small eyes. So badgers. So there are 12 species, 5 genera, and 4 subfamilies. And we look at the honey badger. I think everyone knows the rattle, which doesn't only occur in Africa, it also occurs in India. Hog badger, who's a really cute little fellow over here. and the Javan ferret badger, who's this really cute little fellow over here. All of them are completely nuts, but the honey badger is by far the worst. So we're going to talk about honey badger venom immunity. So up to 25% of a honey badger's diet comprises of snakes, okay? And snakes a lot of the time are venomous, especially the bigger ones. And snake venoms have up to 100 different toxic proteins and other molecules that are potentially fatal, depending on obviously on the bite and depending on the animal. So because of this, honey badgers have to have multiple lines of defense against various snake venoms. And so they're coming in, it's not just a simple plaster, one size fits all. You need to have multiple layers of defense. It's really, really difficult in order to just handle a snake bite and walk away from it. So to think about, we're going to talk about the chemistry that's involved in this. So one of the, I don't know if you guys know much about venoms, but the three kinds of venoms are neurotoxic, cytotoxic, and hemotoxic. Neurotoxic affects your nerves, cytotoxic affects your cells, and hemotoxic affects your blood. We're going to talk specifically about neurotoxic and cytotoxic venoms here. Most of the neurotoxic venom come from cobras and their kin, the elapids. We're going to talk about snakes in the future. So neurotoxic venoms inhibit the transfer of signals between the nerves and muscle receptors. That's all they do. They just literally plug the muscle receptors. And they're known to be, they're also, these nerve receptors are also called nicotinic acetylcholic, I can never pronounce this word, acetylcholic receptors. And since the receptors do not receive instructions, they shut down, i.e. the heart and lungs stop. So plugs the receptors don't receive signals, and the system just shuts down. And the neurotoxin protein acts like a plug to these receptors. And I'll show you some pictures now to make you understand. So you can imagine over here, these are the actual receptors, and they're just simply passing signals between each other. And if these little receptors get plugged, you cannot receive any sort of information, and your body just stops functioning because it has to be told every time that it has to do something. Every heartbeat, every breath, every little flash of muscle in your entire body, it has to be instructed to do that. It doesn't do it automatically. Your brain is controlling every function. Okay, so honey badgers have mutated receptors that cannot be plugged by the neurotoxic proteins, but can still receive signals. And the way this works is that basically the actual receptors are mutated in such a way that the proteins from the venom don't fit. So if you're thinking about a AAA battery, but you've got a AA hole, it's just not going to fit. Okay, and there's always some gaps and some space that the signal can get around. So if you look over here, a cute little picture over here. So this is you can imagine this is the venom protein. It fits into this neuroreceptor perfectly, plugs it, cannot receive any signal. However, a modified or mutated receptor has got these little gaps in it, and though the actual venom actually plugs part of it, most of it still remains operational, and it can actually receive signals indefinitely. Over time, that venom will break down and function will continue as normal. So the honey badger may have some respiratory problems. He may feel a bit sluggish because he's not operating at 100%, but most of the signals are still getting through. Now, cytotoxic venoms work on a totally different story. They end up actually destroying the cells, and they can cause severe clotting. They cause what we call necrosis. And as the venom spreads throughout the body, it causes severe swelling, clotting, necrosis, and just a whole, basically just mass shutdown, rupturing of cells. It's just an awful, awful, awful way to die. A neurotoxic bite is far more comfortable. And you can see over here, this is what's happened. They put a drop of cytotoxic venom in a vial of blood and literally coagulates it in a couple seconds. So, and that's part of what it does to you. Not only that, it does a variety of other things. But one of the biggest problems is that it causes this clotting. So, honey badgers actually have extremely high levels of oprin, which is a natural protein that prevents clotting of the blood vessels. So we actually use this as an anticoagulant. If people have heart surgery, they would actually have oprin as part of a prescription medicine, and it would help you thin your blood out and you'd be able to survive. So it's prescribed not naturally, prescribed by doctors, and honey badgers have high levels of this, up to 6 times higher than what other mammals do. On top of this, they also have a series of other proteins, which admittedly I don't know much about, so I'm not even going to try to discuss with you, so I'm not a toxicologist. And these actual proteins cancel out the cellular breakdown caused by the venom. So these guys are just built for conflicting with snakes. They're kick-ass. They're fantastic. The honey badgers don't have much, as far as we understand, much immunity to hemotoxic venom, but there hasn't been much study into it because the incidences of honey badgers actually being bitten by boomslangs must be incredibly low, and we don't really know how far the impact of hemotoxic venoms would be, but judging by the fact they have this open, it would probably be comparable to what a cytotoxic bite does, as in not much. Okay, so wolverines, which are not true badgers, but they are related, and martens, which are related to ferrets and weasels. So there are 10 species worldwide. They're found across the Americas and Asia. Everyone knows wolverine, although the animal is far cuter and possibly more terrifying than the comic book character. And some of these guys include the OTARIIDS, which is kept as a pet because, again, they're highly intelligent, but they have a habit, much like pit bulls, of turning on their owners. And wolverines, completely barking mad, and limited to the North America. And the Japanese marten, who's a super cute little fellow over here, also really, really mad. The mustelids have a habit of being completely mad. Very little regard given for their personal safety, and that's just, again, due to the toughness of the animal. One of the things you also find with mustelids in general, they tend to have very loose skin around their body, which allows them to get injured without actually getting punctured, getting punctures into their vital organs. It also allows them to turn in their skin. So if someone grabs their neck, they can pretty much do a complete 180 and turn around and bite the predator that's attacking them. Okay, so now we're going to look at two groups over here, which are the weasels, the polecats, the ferrets, and the minks. And these guys include a wide range of similar structures. And they have high levels of metabolism. And in some species will kill over 20 rodents a night. In fact, in certain species, they've recorded up to 60 rodents a night, like the least weasel. They are highly competitive with mongoose species, with one or the other species dominating the other. Mongooses are feliforms. And we've seen that ferrets and weasels in many areas, once they get introduced, they just completely annihilate the mongoose populations. And that's one of the reasons why mongooses are banned as pets in Africa, in Southern Africa specifically, because there's a deep concern that although our striped weasels don't really impact the mongoose populations, if weasels became invasive in Southern Africa, they would completely annihilate our mongoose populations because they just are better, quite frankly, at surviving. And you'll probably find in the next million years or so, a couple million years ago, mongoose populations will be gradually extirpated out of areas by weasel populations across the planet. So these members also spray anal gland fluid like skunks, but they're not nearly as potent. You still don't want to get sprayed with it. And they have 7 species, which is the African striped weasel, this guy over here, heard about in Africa. I've never seen one in my entire life. But a question. Yes, same reason why ferrets are banned as pets. Ferrets and weasels are related, and again, they just breed very well, and they would just annihilate the mongoose species. So we don't want them, as cute as they are. So the next group is the marble polecat, really cute little fellow. Okay, so these are the ICTONYCHINAE, which are, again, not the true weasels, and we call these guys the polecats. But even though the common name is weasel, in Africa we call it the African polecat or the African striped weasel, and they have anal glands. True weasels don't really have anal glands in the same capacity. So true weasels include weasels, stoats, ferrets, and minks, and they contain the world's smallest known carnivore, the least weasel. And this guy can weigh down to 26 grams. I mean, it's a tiny little thing like that size. Super cute. And of course, the minks, horrifically farmed for beauty products and for fur coats, just absolutely horrific. I visited a mink factory in China when I lived there, and it was jarring to say the least. Stoats, which are these glorious little guys over here, and the black-footed ferret, who's this wonderful little ferret again. And again, you can see ecologically the almost identical type of appearance and behavior these guys would have with mongooses. And because they breed faster and they just are a little bit smarter and they eat more in one evening, they would slowly over time start to compete with mongooses. So the last group we're talking about are the otters, the LUTRINAE, which are highly specialized to aquatic lifestyles. Much like all mustelids, they are habitual burrowers, but these burrows are not built on land, they're built along rivers and coastline habitats. They have multiple layers of fur which trap air, and this both insulates them and makes them buoyant. It actually traps air inside the fur layers, and they float wonderfully. And the largest species is the giant otter from the Amazonian basin, 1.7 meters long. He's a big boy. Okay. So there's 13 species worldwide. There's the giant otter. This guy over here looks fairly snake-like, to be honest. The sea otter, super cute, and they actually are no well-known tool users. They actually use rocks to break open clamshells. So again, highly intelligent. And the Cape Crawler's otter, who's a super cute little fellow over here, also quite smart. So these guys also have more needle-like teeth because it's more for piercing and crushing shells, and also for biting fish. So they don't have that strong emphasis on a carnassial shear. But again, you can see there's still a sagittal crest, but it's not as pronounced because they don't need that intense biting power. Okay, so those are the caniforms. So hopefully you can talk about the caniforms with some level of knowledge. Obviously, there's a lot of ground to cover. But we look at the digestive systems of caniforms, particularly dogs. And I'm sure we're all fairly affiliated with what dogs do to our gardens. So dogs' digestive tracts are fairly simple. There's a simple sac stomach with a very enlarged liver. We're going to discuss that now. And a very short, basic digestive tract. The cecum is underdeveloped because they don't need it, because they're not digesting cellulose. So animals that are herbivores digest cellulose. Okay, one of the things that we have to talk about when it comes to livers is a concept called biomagnification. And it works the same as a trophic pyramid. So up each level of the actual pyramid, resources become more and more and more finite. Like this, with the resources, toxins actually amplify in every level of the actual layer. So you'll have a certain amount of toxin in the water, and that gets absorbed into the soil, it's concentrated slightly. Plants and grasses and seeds are concentrated slightly. Herbivores and insects are eating these plants and grasses, concentrates it even more. Omnivores and small obligate carnivores are eating these animals, concentrates even more. And finally, the obligate carnivores are eating large numbers of toxins. And this is the reason why carnivores have these huge developed kidneys and also livers, because they're processing large amounts of toxins. And that's why it's also a terrible idea to ever eat carnivores. You just shouldn't eat dogs. You just shouldn't. You shouldn't eat cats. Never mind the ethical obligations, whatever. It's just really bad for you, shockingly bad for you. Okay, because this is basically where, and you can imagine, let's just say any toxin, call it cyanide. And plants it'd be 10 parts in a million. A herbivore eating them over time would build up to 100 parts in a million. A secondary predator would accumulate 1,000 parts in a million, and an apex predator would finally accumulate 10,000 parts in a million. So you can just see over time this toxins build up. So you ideally want to be eating herbivores and plants. You don't want to be eating predators. So even predatorial fish, you don't want to be eating predatorial fish for the exact same reasons. That's why eating mercury is so high now in predatorial fish populations, because they are eating everything else in the food chain, and we're eating predatorial fish, which everyone likes to eat. So one of the ways that predators combat this is by having high levels of vitamin A in their system. Another question. Someone has their mic on. Guys, if your mic's on, please turn it off. We've only got about 5 minutes left of the lesson anyway. So canine levels have high levels of vitamin A to combat these, as part of the ways that they actually deal with the toxins in the system. And this is the danger with eating canine livers or any sort of predator's livers. You just shouldn't, especially the meat, even more than the meat. You should not eat the liver ever. You can get a condition called hypervitaminicosis. Say that 3 times. And this is a really awful disease. Well, it's not a disease, it's bacterial, but it's a condition that happens to your body if you consume liver, and you can die from it, and you'll die in agony. You'll get nodules all over your bones, you'll get locked jaw, your body shuts down, you start having seizures, and you start having hallucinations. It's just awful. So one of the guys that actually happened to was Xavier Metz. He was a Swiss explorer. He died exploring the Antarctica in 1913. They ran out of food on their expedition, and about 100 kilometers from the nearest station for supplies, they started, or a couple hundred kilometers, they actually ran out of food, and they started eating the huskies. And this poor fellow, they reckon that he died. The reason why he was hallucinating so much and in so much agony is that he actually ate the liver of one of the huskies, and he died in agony about 100 kilometers before they got back to the relay station, or the the supply station. So he died at the age of 30, unfortunately.
He
was a well-known explorer, but at this time they didn't know about vitamins, and they didn't know about a disease called hypervitaminosis. They've also found that signs of hypervitaminosis on caveman bones, especially Neanderthals and Homo erectus bones. So don't eat livers from cats or dogs or crocodiles. Okay, we've got another question. Yeah, again, mics, guys, please turn your microphones off. So, all dogs are domesticated, or all domestic dogs are descended from the European grey wolves, mostly the Europeans, because that's where most of the ancestral cavemen started domesticating them. The grey wolves are spread throughout the world. So it's estimated, looking at the molecular clocks and also just from not even the fossils, from the bones and the sites that we've been exploring, that dogs were fully domesticated around 30,000 years ago, possibly even older than that. But we have ample evidence that 30,000 years ago we were working with dogs. And the accepted hypothesis is that wolves partly self-domesticated themselves by living near ancient human settlements. They would, steal scraps from around the fire. They would eat out of the garbage dumps, and they would just become self-tamed. Like I'm sure you've seen a lot of animals just self-tame themselves. Over time, humans started working cooperatively with them. They started taking pups to live with them, and they would actively breed the ones they wanted. They liked certain genes. They liked a dog that was slightly more friendly, so they would let them breed with the female next door. They liked a dog that was slightly better at smelling, so they would breed that one. And over time, we bred into the various strains today. So humans and dogs have a history going back well over 30,000 years, and so we are codependents as much as any marriages. Okay, so just some cool pictures from how humans and dogs would have lived back in the day. And even back, ancient sand paintings dating back over 10,000 years have showed pictures of humans and dogs living together, cohabitating. So they are really part of us, and part of one of our successes and why we exploded in the last 50,000 years in terms of the species, and why we just dominated this planet. We had, all of a sudden, we weren't having to chase down our own prey, we had to chase down prey for us and save us a lot of our, we used our brains to do all the hard work, and we got the dogs to do all the killing. Okay, so and that is the history of dog breeds. And we went from the grey wolf. There are several strains. There's the European strain, the North American strains, which is still fairly wolf-like, the Chinese strains, which are fairly wolf-like, and the Indian strains, which are really weird. I think the European strains are by far the most diverse in terms of just the weirdness you get out here. Chihuahuas coming out, pugs and Pomeranians and all sorts of the weird things, Great Danes. But obviously when you look at your more classic breeds, Huskies and various other things like that, they are still very wolf-like in their appearance. So I've got a question. Okay, please, I don't want to say names, but Karen, please turn your microphone off. I'm going to see if I can mute. All right, there we go. Okay, so a lot of complaints coming through. Guys, please mute your microphones during every session. Q&A, we can ask questions. Okay, so that is our class for today. Sorry about the last little bit. Apparently there were some people who couldn't hear anything. Some of the references for tonight, I hope that you guys enjoyed the class, and we're doing Feliforms next week, which will be a two-part series. Q&As tomorrow night, 7 o'clock, and I hope to see you there. Hopefully you guys enjoyed. African polecat and striped weasel. So striped weasels are slightly different. We'll do that tomorrow night in the Q&A. Okay, so we'll, again, with this speciation, but we'll just talk about that tomorrow night. Okay, thank you guys. See you tomorrow. Auf Wiedersehen. Adios.
Cheers, bye.
Yes. Assalamu alaikum. Zaijian, sayonara, aloha, and so forth. Cheerio. Okay, we've got questions coming through. No. Okay, thanks everyone. Cheers. Bye-bye.